Good morning to all of you. I am Dr. Murali, Professor in Computer Science and Engineering at Maharaja Institute of Technology, Mysore. I will be dealing with the second module of data structure. Basically, that deals with stacks and queues and little bit of recursion. This chapter is a little bit lengthy compared to other kind of chapters, wherein which other modules consist of only one type of data structure like linked list or trees or something like that. For example, third module consists of only linked list, whereas this module consists of three different chapters. One is about stack, second one is about queues, and third one is about recursion. Since they are all related, stacks, queues and recursion, they are related, so these three are put in one module, and you will be really seeing these three things together. Sometimes you will be mixing up the contents of this module, this stacks to queue, and once you know a little bit of stack, you will be knowing about queues also easily, and of course to execute recursion you need to know about stack. So this particular module, second module, will be dealt with, as I already told you, three kinds of data structure, two kinds of data structure and one implementation, something like recursion. So first of all, let us look at what exactly there in the syllabus. So therefore you will come to know the quantum of work or quantum of knowledge you will be knowing from this particular subject, this particular module. Basically this module consists of stacks. You will be knowing about definition of stack, and you will be knowing kinds of data structure like stacks, different kinds of data structure you have. There are two kinds of stacks you will be studying in the syllabus. One, you will be knowing about static stack, which is basically implemented by using arrays, or you will be implementing stack by using dynamic. If you are implementing stack by using arrays, then it is called static stack. If you are using dynamic implementation, you are not using array. You know the limitation of array. Array is basically having limited space, so fixed size. So obviously you need to go for varied number of data to be stored in stack. If that is the case, you go for dynamic. So therefore two kinds of stacks you will be knowing. One is called implementation of stack by using arrays, which you already studied in module 1, or you will be using dynamic memory allocation to have space for stack. So that is called as a dynamic stack. In dynamic stack, you will be understanding first of all how to insert element into stack, how to delete element into stack from the stack, and if at all if there are any kind of overflows which are there, if the size is crossing the limit specifically in static stack, so that will be seen with a overflow or underflow. So these are the usual things you have studied in your previous module. Any data structure, if you look at this, there are two things you will be dealing. One is called overflow and underflow. You are trying to add some element into a data structure wherein which has already crossed the limit, then it is called overflow. Underflow, wherein which you are trying to remove an element where there are no elements. So this is called underflow. Any data structure for that matter, you need to handle these two status before inserting and deleting. If at all if you are inserting an element, you have to check whether there is a space to insert. If at all if you are deleting, you have to sure that there are some elements in the data structure. So that is true even for stack also. So even in case of stack, you will be checking about overflow, underflow, these kind of things. You will be studying about insertion, deletion kind of operations in the stack. And next you are going for some implementation experiments, something like infix expression to postfix expression. So you will be seeing these things in the subsequent classes. Similarly, the next chapter in the same module is about queues. Stacks and queues are going together one by one. They are associated. The way in which you remove the elements will be decided by the decides whether it's a stack or a queue. We will be seeing those things later. So, in the queue also you will be implementing either by using a static representation by using arrays, or are you going for queue representation by using dynamic memory allocation. So, these are the two kinds of storage space that you can allocate for queue. You will be studying these things, of course, overflow, underflow. There is a specific category of queue called circular queue. You will be studying about the circular queue. What are the advantages, disadvantages, you will be seeing. Some applications of queue like priority queue. There is one specific problem which is there in your syllabus called maze problem, solving this maze problem. So, these things are there in your syllabus about queue. Similarly, in the third chapter of the same module, you will be studying some recursive algorithms. You heard of recursive algorithms in second semester or in first semester class. Recursion basically trying to implement the same repetition by using the same variable. Similar operation is being carried out on the same procedure itself. These kind of recursion will be studied. Some examples like GCD, factorial, Fibonacci, Ackermann solution, Ackermann problems. So, these are some of the examples which are there for recursion. So, these things if you complete, then stacks, queues and recursion comprises, put together is basically second module. I will be dealing about these three things in the second module. Maybe I am taking around 10 sessions to complete this. Lot of problems to be solved. Implementation of stacks, queues and recursion by using a programming language, preferably by using C program, will be discussed, and also some problems will be solved, so that this whole stacks and queues implementation will be studied. First of all, before getting into stacks itself, you got to know the definition which applies, which is suitable for any kind of data structure. What exactly data structure? Data structure is basically a mechanism by which you will be trying to store the data into the memory location and retrieve it whenever you wanted. This is very important. Storage of data in a systematic way, so that whenever you want, you can retrieve it so quickly without any kind of delay. Of course, the delay will be only for searching, but these algorithms, these mechanisms by which you will be storing, like arrays or stacks or queues or linked list trees or graphs, these are all the ways of storing the data inside the machine. Why we have varieties of data structure? Varieties of data structures are very much essential because you need to use them on a different applications, on a different types. For example, data structure like stack will be used on a specific kind of applications wherein which it is there in a systematic way. It is called as first in, first out. That's called queue. Last in, first out, that's called stack. I mean, there is a systematic way in which you will be retrieving the data. So, based on that you will be storing it. So, therefore, the data structure definition is something like this: trying to store the data inside the machine such a way that whenever you want, it can be retrieved. It can be retrieved so quickly without any kind of delay. Even you would have seen this in your ATM machines also. ATM machines holds huge amount of account holders data of the entire nation. Take the case of State Bank of India. They would have hold that account numbers of all the customers' account numbers in the repository. When you go to ATM machine and put your card, give your identification, the ATM machine in the local ATM machine should retrieve the customer details your account number and amount you have in your this thing and your credit limits, all those things should be brought from the server to this particular machine well within time. This is possible only when at the repository everything is stored in a systematic way. So therefore, all this data structure, arrays, stacks, queues, linked list, all those things, trying to store the data in a systematic way. So therefore, you can retrieve it. Okay, so let us get into stacks. Stacks is basically a data structure used to retrieve the data in a specific way. You cannot just retrieve it like a random. See, there are two kinds of retrieval of data you have to understand. So one is called random retrieval. What is this random retrieval? Say for example, take the case of array. In case of array, elements are stored in the form of in the successive locations, and you can retrieve any data randomly. Whereas rest of the data structure you will be discussing, like stacks, queues, linked list or trees, doesn't permit you to access any data randomly. So that is a speciality. Say for example, here in case of stack, there is a specific way in which you can retrieve the data from the data storage. There is a specific sequence, there is a specific rule. What that rule says? It says you can retrieve it, the data which came last. This is also called as last in first out. Last in first out. So queue is called as first in first out. What does it mean? Now there are two types of retrieval I told you. One is called random retrieval and second one is called the systematic retrieval or non-random retrieval, you can consider. What do you mean by that? Take the case of array. This array, if you store elements in the array, say you call this is A, this is 0, 1, 2, 3, 4, 5, something like this. You have stored all the elements inside the array. Let us consider you have filled up some data. Something like this. You have liberty to pick up any data randomly. Say for example, I would like to access A of 3. I can go and get it. After that I can go to A of 0. Then I can go to A of 5. You have liberty to go to any location and pick up the data. So this is the speciality of array. This facility is there only for array. Rest of the data structure you will be studying in the syllabus from second module onwards. They don't permit like this actually. You cannot access or you cannot retrieve whatever data you wanted on a random basis. You need to apply some specific rule to retrieve the data. So these rules are something like this, LIFO or FIFO. So which one to be picked up out of the source, which one to be picked out of the data repository, which came last into this data storage, so that will go fast. Similarly, in case of queue, which came, as the name itself says, we use queues in most of our conventional in a cinema theater also we see, even in the temples also we see people are there in the queue. Who goes first to the queue, you will be serviced, something like that. So that is actually the queue. It's the same name has been kept here in data structure called queue. Even in the stack also the similar kind of mechanism we come across in our daily life. Say for example, assume that there is a vessel which can hold lot of plates. So you will be keeping one after the other. So you will be just keeping one after the other. So the one plate which is just kept into the vessel, so that will go and occupy the last thing. And similarly, you will be just keeping one after the other. You will be keeping stack of the plates one over the other. So once the vessel is full, you can take out the plate which came last to this vessel. You will be finding plenty of applications in computer science for stacks and queues. Now I am talking about this stack in which assume there is a vessel, lot of plates to be kept here inside this vessel. So you will be taking one plate and you are keeping it here, and you take the plate and keep it inside this. So now each of the plates will be occupying the seat which is there at the below, right, and it is just coming up. So once it reaches at some point of time, at certain point of time, you would like to take away one plate, you know that actually which came last to this vessel, so that is going first. So this is how most of the cases the elements which came last will be just going fast. So this is what the phenomena we got to understand. Even in the conventional classroom also, people who just come in always try to occupy the last bench in the class, and the fellow who just came last obviously will not find any last benches, obviously will be sitting in the front. Now when the bell rings and the teacher goes, the fellow who goes first out of this classroom will be the fellow who is sitting in the front. So therefore that fellow came last to this classroom, now this fellow is going first. So these kind of data which comes to the data storage last, so that is going first. So that mechanism, that structure, that architecture is called as stack. So that is also called as last in, first out. The name itself says last in, that has come last, now which is going first. Now coming back to this particular mechanism, you see here in this vessel you are kept, assume that this vessel can accommodate 100 plates. Now assume that you have filled up 50 plates out of this. After filling this 50 plates, I would like to take away one plate out of this 50 plates, one which came last, so that is taken first. That is taken first. Now here I would like to pick up the 20th plate which I have kept. Now there are 49 plates because I have removed 50th one, there are now 49 plates. Now I would like to go to the 20th plate. If I would like to go to the 20th plate, or would like to take away the 20th plate, here in this architecture not possible straight away. You have to remove 49th, then 48, then 47, keep removing all the plates till you get the number called 20, then you can remove that. So this is the speciality of this data structure. Whereas if you look at random retrieval data structure, something like array, for example, if you have kept all these elements in this fashion, I can go to third element, do some operation on this. I can do changes, do the deletion or whatever operation I can do. I can just do addition, insertion, anywhere. It means arrays permits you to allow any location randomly, any data randomly. Now you can ask me, what is the real difficulty with respect to arrays? Arrays finds very difficult, especially with respect to insertion and deletion. Insertion, if there are some specific way of arranging the data inside this array, it will not really look at the empty spaces. So you need to push the elements. So you need to push the elements or pull down these elements. So obviously array has got difficulty, especially with respect to insertion and deletion. Specifically, say for example, already there are some elements which are already kept in the array. I would like to insert one element in between. If you would like to insert an element in between, actually you have to push all the elements down by one position. So that is a difficulty of this array. And array, as the name itself says, has got a limited amount of size. So you would have seen this in the first module. But now I am more interested in talking about this randomness. Randomness is allowed in case of array, whereas randomness is not allowed in case of any other data structures you will be studying from second module onwards, obviously for stacks and queues. So this you have to register as a first thing. There is a difference between arrays and stacks, especially with respect to accessing. Stack doesn't permit you to access randomly. Is it an advantage? Yes, though it looks that actually accessing any data randomly is an advantage, it looks at the outset, but as we proceed, we will be really looking the advantages of not accessing the data randomly. That itself is an advantage that I am trying to derive in case of the stacks and queues, or in subsequent data structure we will be seeing. So therefore, randomness, some cases it is advantageous, but not in all the cases. Sometimes it is advantageous, sometimes it is disadvantageous also. Okay. Now let us look at what exactly the stack. Okay. Now let us look back implementation of this kind of data structure. I already told you, try to understand the stack. As I already told you, stack is basically last in, first out, or you can also use another way, first in, last out. So this is another way of also defining this. So element which came first will go last, or element which comes first, last in, first out, or first in, last out. So these two are the two abbreviations you can use for stack. Okay. Now there are some implementation differences between the visualization that I am doing on a stack, on a conventional system, and what we are implementing inside the machine by using variables and some kind of primitive data structure that we will be using for storage space. Okay. So first of all, let us try to understand how exactly the plates go into the vessel. Assume that this is basically a storage. This particular storage trying to take the plates one above the other. Okay, now this is how you are keeping it. You are inserting from the top of the vessel. This is your vessel, and you are trying to insert from the top. So plates are going one by one to this, like this. Now 1, 2, 3, 4, 5, 6, 7, 8 plates have been kept here, right? Now, if at all if you would like to take away any plates out of this vessel, obviously this should be taken, not this. So that is why it is called last in, first out. So this plate came last to this stack or storage or vessel. So therefore this is now going first. This is going first. So like so it is there. So once you take out this, I can insert one more plate, something like this. So this is the mechanism which is there in stack. First, two things you have to understand. One, in a very similar way, are we implementing by using computers? No. This is only for imagining and trying to visualize the stack which is there. The second thing, in a very simple way, how to understand the applications of this stack. Take this small case. Now, assume that I am now taking class here, and in between, say for example, it is a 1 hour class. In 1 hour class, if I am there halfway through, suddenly there is a knock on the door. Somebody comes and say that, sir, I would like to say something for you. There is an interruption in the class. Now assume that I have written something on the board. I stop the current work. And attend to the work which is being knocked. Just go there. Assume that there is an attender who has come here to issue a notice to all of you. Okay. Now what is happening now? The current work which I am taking class in the room is now being interrupted, and now I am giving focus to this. All of you know that actually when I go there, do the work with that fellow, when I come back, I don't do from the beginning. I do from where I stopped. This is the usual phenomena. Now, take the further steps in this, further cases of this. Now, when I am talking to an attender, by that time, assume that your HOD has come and interrupted, I would like to talk to you. Now, I stop the work talking to attender and I give attention to HOD. So, I am now talking to head of the department. When I am talking to head of the department, I am halfway talking to head of the department. By that time, assume that your principal has come and you would like to talk to me. Now, I stop talking to your head of the department and I go there, talk to principal. Now, assume that now there is a series of interruptions which have happened in between all these classes. When you complete the interrupted work, where you have given the attention, focus, when you come back, where to come back? If you are a human being, you know that where you stop talking to attender, where you stop talking to principal, where you stop talking to head of the department, where you left the class. As a human being, you will be really knowing about where you stopped. If you try to imitate the similar exercise with respect to the computer programming, assume that you would have seen lot of programming languages in which there is a program in which you will be running some kind of programs and suddenly you will be switching on to this function. Calling a function you are very familiar. So, call this function. Call function A. It means you stop doing the current work and you are going to this function. It is as good as you are doing this class, from this class there is an interruption, you go to this attender, assume that attender has called. It is something like that even in your programming languages also, you will be running some program, suddenly you need to go to some other function, calling function, calling procedure, calling function, okay, you are going there. Assume that when you are doing all this works here, so in between you need to call some other function. Very similar to calling, there is an interruption by head of the department. When you are talking to head of the department, by the time, assume that there is an interruption in between and now you are now talking to this principal. Now, look at the application of stack. Why these stacks are being used? Now you call this is stack. This stack holds the location where I left the respective programs. Say for example, this is your main program. Before you go to any of the subfunction, before you go to the door, you try to memorize where you have stopped. In a very similar way, before you go to this function, when you call this function, before you go there, try to remember the location at which you stopped the work. It means, so main function at line number 15, I stopped. Okay. So line number 15, this is 15th line. It means I was there at the 15th line. At 15th line, I went here. It means some other lines which are there in this program to be executed later. Now, when you go here, this is also another program. When you are doing this kind of program, it is very similar to you are talking to attender. By the time your HOD has come, so therefore, when you are talking to your attender for some time, when your HOD has come, this is the line number 5 in function, I am calling it attender. This is function head of the department. This is function principal. So, at line number 5, there is an when you are doing some talking with attender, your HOD has come. So, I mean, when you are executing line number 5 in this program, when call has come, you are going here. When you are going here, you know that after completing talking to head of the department, you need to come back and do from the line number 6, not from the beginning. How do you know? For that, you are storing it inside the stack and you go. So, before you go there, you store it in here. So, therefore, I am calling here function called attender. I left at line number 5. So, I store it here and I go here. So, I will be now talking to head of the department. When you are there at 7th line, an interruption has come from principal. So, therefore, before you talk to principal, you store the details where you have been interrupted. So, therefore, when you come back, you will be doing it from line number 8. So, therefore, I am storing it here, function called HOD. I was interrupted at 7th line. It means I am supposed to do 8th line onwards. Okay. Now, you come here, you talk to principal, you complete the work. Once you complete the work with principal, common sense says I have to go to head of the department and complete work. When you are doing that, from where I have to do? I should not do from the beginning. I have to do from the 8th line. How do you know? You pick up from this. You pick up. So, therefore, last in, first out. First in, last out, or last in, first out. So, therefore, one which is now being taken out is this. It says function HOD, you stopped at 7th line, you continue from 8th line. So, therefore, this has come out. So, therefore, this has been taken out. So, you complete all the work here. After completing all the work, I have to come back to talk to attender. Where I stopped? I stopped at 5th line. How do you know? You pick up from this. When you pick up from this, I will be knowing this is at 5th line. I have been interrupted. I have to do from 6th line onwards. So, you do execution of 6th line. Once you complete all the work with attender, you come back here, you come back to the class. From where I should do is kept here, memorized. So, therefore, what is stack? It is trying to memorize your sequence of operations you carried out in a specific way. So, therefore, basically data structure like stack is basically trying to store the sequence by which it has come, and it is trying to output the way in which it has come in an opposite way it is trying to give. So, therefore, what is this stack? Basically, it is a memory, trying to memorize the sequence in which it has come and trying to give the output in this way. This is called LIFO. So, if you understand this for stack, it is very, very similar for queue, right. So, we will see that in the subsequent classes, but right now we will try to understand the stack. Okay. Now, once you know this particular phenomena, there are plenty of other applications you will be seeing it in the class, of course, because of limitations of the class. So, anyway, some more applications will be dealt in the thing. Now, one major thing that you got to realize now, keeping stack is advantageous. It is a memory, it is basically trying to memorize the sequence of events which have happened, and you are trying to do it in a reverse way, trying to take out that in a reverse way. So, this is how you are supposed to understand. When you are trying to implement this by using the machine, there is a slight difference that you got to start imagining. Okay. How to visualize, how to start implementing this? Okay. See, there are two ways by which you can implement the data structure called stack. One, by using arrays, or by using dynamic memory allocation mechanism. When you are using the data structure called array, now array is used as a memory element. Now, one question may be there with all of you, that, sir, arrays permits to access data randomly. You are using arrays to store elements of the stack in a static stack by using arrays? If that is the case, is randomness is allowed? No, randomness is not allowed because you are using this array only as a data storage elements. Array is used as only data storage elements and works as a stack. So therefore, all the rules of the stack will be applied, and array is used as a data storage element. So therefore, you should not have all the characteristic of the array. Array permits you to have random access. No, you are not supposed to access randomly any data, because in case of implementation of stack by using arrays in a static representation. Okay, let us see first two things. One, static and dynamic. Dynamic stack and static. Name itself says static means limited size, and here it is unlimited size. Limited size. Limited size, obviously I can go for array. Here I can just go for a dynamic memory allocation and have varied number of data storage elements to store the stack. But in principle it works as a stack only. But storage to store the elements, I am using arrays over here, because already well defined data structure like array is there. So therefore I am trying to go for that. Okay. Now, when I am trying to look at implementing stack by using arrays, then it works as a static stack. Take this case. Now, there is an array. I am calling the name of this array as stack. You are familiar with that actually, every array will have a name. So therefore, I am calling the name of the array as stack. You know that this will have so many locations, depends on how you are defined. If I have defined this as 6 size, so then it is A0 to A5, stack 0 to stack 5. So this is how the storage can be there in the memory. All right. Okay. Now, coming back to this vessel problem, I told you to start visualizing, imagining. It is just like a plates kept inside the vessel, right? Now, so many plates will be brought down here. Say take this plate number 1. When you put this here, you know that this plate will not stand here, it will not float on the air. Because of the gravitation, it now comes here. When you put the second plate here, this is where the opening is there. In case of stack, opening is there only at the one end. Insertion should happen in the same, deletion also should happen in the same. It is just like our class door. In the class, there is a door. For what reason? In your house also, we have a door. For what reason? It is not only for input, it is also for output. You can come in, you can go out in every door. So therefore, in a very similar way, stack will have only one entry, and in the same location there is the exit. So therefore, in this vessel, you will be inserting here and you will be taking out there itself. So that mechanism is called as the speciality with the stack. Okay. Now when you put the second plate here, it falls onto this and sits over here, a third, fourth like this. Why? It is only because there is a gravitation force, there is a weight of this plate and it will fall down onto this. Okay. Now can I implement in a very similar way here? It is not so. Now because when you put, say for example, I would like to insert a number called 20 into this data structure called stack. When you put 20 here, it does not fall down, because it is only an imagination, it is only system that I am trying to implement this. It does not have any kind of gravitation force. So therefore, if you put this 20, it will be there itself, right? If you put the next element, here you cannot put. So therefore, So you have to start imagining when you are implementing data structure, understanding stack in the form of vessel, it is good. Now only one difference you have to make it out. What is the difference? Here in case of vessel, the opening is fixed. It is there at the top of the vessel. Top of the vessel is open, so therefore you can insert and do the deletion. Now can you start imagining this in other way? Now the opening itself is moving. Elements are fixed. Opening are moving. This is how you have to start imagining. Now for example, people are there in the queue to issue tickets, to get tickets. There is one fellow who issues the ticket. He is fixed. He is sitting here. Now all the people who are there in the queue, they will be moving. They are the elements. They are moving, and this fellow is fixed. Whereas, can you start imagining other way? Now people are there in the queue. This fellow himself is moves. This is one way. Or so this vessel, when you start imagining this vessel, here that the location at which the insertion and deletion happens to this vessel is fixed, whereas the data elements moves up and down. Here in case of this, actually plates will be taken out by your hand and will be taking it out, and similarly when you are putting it, because of gravitation it falls down. It means the elements are moving. The opening, this is called as vessel top or stack top. The stack top is fixed in case of this, whereas when you are implementing by using computers, you have to understand that this is not possible because there is no gravity there, right? So you have to make the stack pointer or the vessel pointer or the vessel top itself moving, whereas the elements are fixed. It is one and same. Either the element should move and the stack pointer at one location, or stack pointer itself moves, elements are fixed. Say for example here, take this case. Now I would like to insert 20, 25, 63 and 18. So these are the sequence by which the elements are to be inserted. You know that actually if 20 is inserted first, after that 25, next 63, next 18 should be taken out first. If I make that arrangement, then it is fine. Okay, so what I do is I will just take an array, static array, and I insert first element called 20 here, right? I am calling this itself is a stack pointer, just like the vessel top is moving, right? Something like that. So stack pointer is there at 0. Now I insert next element called 25. So to insert next element, I come down. It means the stack pointer is now moving. Now to insert next, so I will be inserting here, the stack pointer will be here. Now I am inserting next element called 18, the stack pointer is here. Now where you are deleting an element? Deleting an element is from the vessel top only. It means stack pointer. So therefore remove the element which is there or pointed by stack pointer. It means stack pointer is now pointing to 18. It means this element came last. So therefore remove that. Say for example I will remove 18, let us say. Now you decrement the stack pointer. It means elements are not moving, whereas like this elements are moving, the plates are moving up and down. No, here elements are there in the same location. Now your stack pointer itself is moving. The stack pointer now which is there here moved up because you have deleted an element. When you delete an element, this goes up. Now if you would like to delete an element, which element? 63. So that came last amongst these three. So therefore, that will be removed. Or for example, you would like to insert an element. Where you would like to insert an element? Insert an element where it is being shown by stack pointer. So therefore I will just do there. So stack pointer is now moving. So this is the fundamental phenomena you have got to understand. It is applicable even for stack and it is even for queue also. If you understand this phenomena of moving of stack pointer and elements are fixed. So, then majority of the understanding implementation by using computers will be very, very easy. In the next class, we will see how exactly the insertion, deletion and how exactly this dynamic memory allocation will be happening. We will see that in the next class.